We're going to be looking at example 4, parts A and C in your section 4.1 notes. In this example, we'd like to find the critical points of our function. We do that by looking at interior points, and we're going to call them C, of our domain, where the derivative at that point is 0 or the derivative fails to exist. So in part A, we won't have any places where the derivative is going to fail to exist because this is a nice polynomial function. So we start out by finding the derivative, which is pretty easy to do using the power rule. So if we bring the 4 down, it'll cancel. Drop the power by 1, we're left with x cubed. Bring the 3 down, it'll cancel. Drop the power down, we're going to have x squared. And then here, bring the power down, we're going to have minus 6, and then dropping the power down, we'll have x. So that's our derivative. So now we're going to see if there's any spots where this derivative is equal to 0. Okay, so I set the equation equal to 0, and I see if I can do any factoring, which I can take out an x. Okay, so if we take out an x, we continue with factoring. We see if there's any numbers that multiply to -3 and add up to -1, which there are. We can use a -3 and a +2. Okay, so this one completely factors, and we can see our 3 critical points. So the first one is 0, the next one is 3, and the final one is -2. All right, so for part C, our function is a little bit more complex than a polynomial function. So we have a polynomial part, but then we also have a logarithm. So we're gonna have to pay attention and see if there's any places where the derivative fails here. So start off by taking the derivative. The derivative of x squared is easy, that's 2x. Okay, now we're gonna use our natural log rule. Taking the derivative of the natural log, whatever is inside, that becomes your denominator. So we have x squared plus 1, and then the derivative of the denominator is your numerator. So the derivative of x squared plus 1 is going to be 2x. So that part goes on top. Okay, so cleaning this up a bit, we're going to get 2x minus 4x all over x squared plus 1. Okay, so we do have a denominator, which could be an issue. So if we're going to have any points where the derivative fails, it would be here. But lucky for us, this derivative is always positive because of the square term. So we won't have any places where we're dividing by 0. Okay, so we only need to look and see if there's any spots where this derivative is equal to 0. So I go over here and I set 2x minus 4x all over x squared plus 1 equals 0. Okay, so I'm going to go ahead and kick this on over to the other side. So I get 2x is equal to 4x all over x squared plus 1. Okay, so I'm now going to do a little cross multiplication action here to get rid of the fraction. So when I cross multiply, I'm going to end up with 2x cubed and then plus 2x equal to 4x. Okay, now I want to bring the 4x over and see if there's any factoring I can do. So I have 2x cubed and then minus 2x equal to 0. Okay, I definitely can take out the 2x. So when I do that, I'm left with x squared minus 1. Okay, this does continue to factor into x plus 1 and x minus 1. Okay, and we can see from this, we're going to have 3 places where the derivative is equal to 0. So we'll have 3 critical points here. The first one is going to be 0. Then we're going to have -1 and +1. And that completes part C.